Hey everyone, welcome to a video on the unit circle. Alright, so we're going to get started first by looking at the unit circle filled out, which looks like quite a bit of information. We're going to talk about that in a second. But let's go ahead and define what the unit circle actually is. So the unit circle basically has a radius of 1, and it's also centered, at the origin. Okay. And so let's go about just kind of breaking down all of this information, and then we're going to go ahead and recreate it on our own. Okay. So the first thing I want to mention is that really almost all this information can be created based on very simple patterns. So for example, whoops, let me go ahead and put that in here. So for example, if I create a little triangle, a right triangle, let's say, at this 30-degree angle, and this 30 degrees, by the way, is this angle, this reference angle right here. Okay, so if I created this right triangle, then I want you to basically note that the x value, which happens to be the cosine of theta, or this angle, the reference angle, which we'll talk about later on, is the square root of 3 over 2, and the y happens to be the sine of that angle, which is 1/2. And now I'm going to show you how to fill out pretty much almost all of this unit circle just based on that information. Let's go up by 60 or by 30 degrees to get to my 60 degrees. So 30 degrees plus another 30 degrees is 60 degrees. And if you made this triangle right here, it would be another 30, 60, 90 triangle, but that's besides the point. But what I really want you to notice is that this x is 1/2 and this y happens to be root 3 over 2, which happens to be the same as this, except the x and the y's are flipped. Okay, so basically, as long as you know the 30-degree angle, then all you have to do for the 60 is flip them, right? To get the flip the x and y to get your coordinate. All right, now once you have those, right, let's keep counting up by 30 degrees. So here's another 30 degrees to get your 90. Here's another 30 degrees to get your 120. Well, what are the values of this guy? Well, you can literally just take those values and reflect them, right, from the 60 over to the 120, reflect them over the y-axis. And basically it's the same except for the x is going to, instead of be positive 1/2, it's going to go to the left being negative 1/2. The y, the height, is still the same at root 3 over 2. Let's go another 30 degrees to get to 150 degrees. Well, how would I get that x and y? Well, if I know the first 30 degrees, I can reflect that one over, right? Doing the same thing. Let's go another 30 degrees, which we'll talk about what it means to be on these axes later. But anyway, let's go to another 30 degrees, 210. And again, flip this guy over. All right, root 3 over 2, negative root 3 over 2 in the x, still negative root 3 over 2 in that x. And then the y, instead of positive 1/2, it is going down now to negative 1/2. Okay, let's go another 30 degrees to get your 240. All right, and again, you can reflect that guy down here. Let's go to 270 and then to 300. Reflect this one over if you want, or you could have gone up here, right, and reflected this one down. Doesn't really matter. And then finally, we have our 330, which again, you can reflect multiple ways. Let's go from the original, for example, and we're going to reflect that over. Okay, so with really just knowing this 30-degree triangle, keep going here. With just knowing this 30-degree triangle right here, right, you can fill out, gosh, that's like, I mean, what, 80%, 90% of the unit circle right there. Okay, now let's talk about really the rest, because there's really not much to it. The rest is going to be this 40, based on this 45-degree angle. So if I took this 45-degree reference angle and made a little right triangle here, note that this happens to be an x value of root 2 over 2 and a y value of the same thing. And then you can still do the exact same thing. We'll talk about 90 degrees later on. But anyway, let's go another 45 degrees to 135. Well, how am I going to get this? Well, literally, you can just reflect this over. The x is now negative root 2 over 2. The y remains the same. And then you can do the exact same thing, right? If you reflect this over to 225 and then do the exact same thing for 315 as well. And that would complete the entire unit circle. So, what is important to note? Well, we need to know this 30-degree reference angle and the values, right? Root 3 over 2 and 1/2. And we need to know 45, all right? 45, and it's just both the x and y are the same at root 2 over 2, okay? All right, so let's go about, and by the way, the rest of this information up here, this is just saying first quadrant, second quadrant, third quadrant, and fourth quadrant, and it's just showing this plus plus means the x value is positive and the y value is positive, and then over here x value is negative, y value is positive, both are negative, and then for the fourth, x is positive and y is negative. But as long as you basically know this first quadrant, you can pretty much reflect it to any other quadrant, okay? All right, the hardest part really for students is honestly just when you start bringing up radians instead of degrees, okay? But that just comes with practice, okay? All right, so let's go ahead and we are going to remove the this filled in unit circle, and now we have this nice blank unit circle here, okay? All right, and I'm just going to show you, I'm going to turn some things on and off here. Like for example, I am going to, let's go ahead and turn off the 45 degrees because we're going to, like I always go around and do either the 30s first and include the 60s, or I might do the 45s first and then the 30s second. But anyway, we're going to do the 30s first, okay? And so I'm gonna turn off the 60s, but for now, but I'm gonna turn them on in a second because I like to do these with my 30s. All right, I don't differentiate my 30s from my 60-degree angles. Okay. Okay, so let's go ahead and we are going to get started. The first thing that we need to do, and actually, you know what? Let me show you guys before I begin. I'm just gonna turn on all of these, I guess, and show you that all of these have right triangles, or we can create right triangles. And you'll see, so if I turn on these right triangles for the 45s, okay, and then I'm going to turn on the right triangles for the 60s, and then turn on the right triangles for the 30s. Where is that? There it is. Okay, so all of these are, they basically, we're creating these right triangles. And just to be clear, there are an infinite number of points on this particular, you know, on the unit circle. On any circle, there are an infinite number of points. But what we're going to do is basically go through all the ones we can do without a calculator, essentially. That's what we're talking about here. Okay, and so actually, you know what? Before we go over this, let's just cover real quick, just so that we can make this go very quickly. Special right triangles. Okay, so special right triangles are basically your 45, 45, 90, and your 30, 60, 90. And so what I'm going to do is we're just going to just cover this super fast. So the way I like to teach this is I basically use ratios. So if the shortest length of each one of these is always 1, that's where I start off. But anyway, if the shortest length of 45, 45 is 1, then that means the hypotenuse is the root 2. And this other leg is the same, so that's also 1. Okay? And which we're going to actually fill this out in a different way in a second here. But in a 30, 60, 90, if the short leg is 1, then the long side is going to be double that, which is 2. And the middle is going to be 1 times the root 3, so root 3. Okay? So these are basically the ratios. I have another video on this. I like to say special right triangles are as simple as 1, 2, 3. Because all you have here is 1, 2, and 3, and you just kind of have to put the numbers in the right spots. But our numbers are going to be a little bit different, and that's because what corresponds to all of these, let me turn this off and turn on my unit circle. What corresponds to the hypotenuse for every single one of these is the radius. And I told you for the unit circle, it has a radius of 1. Okay, so let's go ahead and we're going to figure out what these values are with the radius, the hypotenuse being 1 for each of these, okay? And we're going to use our same ratios. So let's start with, I guess we'll start over here with the 45, 45, 90. So in order to get this, the way to go this way was multiply by root 2, right? And to go back, I'm going to divide by root 2. All right, so 1 divided by root 2. Well, we don't. We need to rationalize this, right? We don't like to have roots in our radicals in our denominators. So I'm going to multiply top and bottom by root 2. And when I multiply these, I get the square root of 2 over the square root of 4, which is 2. All right, and so the length of the short side is going to be root 2 over 2. And you just saw those values just prior, right? So that's how we're going to come up with these. And let's see here. And by the way, pick any one of these, but say this is my reference angle, 45 degrees. If I did the cosine of 45 degrees, well, what is that equal to? Well, that is equal to the adjacent side, which is root 2 over 2, divided by the hypotenuse of 1. So that is equal to root 2 over 2. This is also going to correspond with our x value, which we're going to see later on. And actually, if I do the sine, it's actually going to be the same thing. So sine of 45 degrees is equal to the opposite, right, over hypotenuse, which is still root 2 over 2. Okay, so whether it's cosine or sine of 45 degrees, it's root 2 over 2. All right, and then over here, let's do the 30, 60, 90. And let's see here. So if I'm going from the long side, the longest side, the hypotenuse, down to the shortest side, before I multiply by 2, so to go backwards, I need to divide by 2. So the short side would be 1/2. And then to go over here, I need to multiply by root 3. So root 3 times 1/2 is just the root 3 over 2. Okay? And let's say that my reference angle, all right, is 30 degrees. All right? The cosine of 30 degrees is equal to what? Well, that is equal to the adjacent side over the hypotenuse, which is root 3 over 2. The sine of 30 degrees, let's see here, is the opposite, which is 1/2 over 1, so just 1/2. And then let's do, what if my, whoops, I guess I just erased that. That's okay. We'll just leave it like that, whatever. Let's use a different color here. Let's say my reference angle was 60 degrees, all right? Well, the cosine of 60 degrees, using SOHCAHTOA, would be adjacent side 1/2 over hypotenuse, so that is 1/2. And the sine of 60 degrees, sine of 60 degrees, is the opposite, root 3 over 2, over hypotenuse, so it's just root 3 over 2. And I want you to notice that these are flip-flopped, right? Cosine of 30 is root 3 over 2, and sine of 60 is root 3 over 2, and vice versa. The cosine of 60 degrees is 1/2, and the sine of 30 degrees is 1/2. And so hopefully you can start putting together these patterns because now we're going to utilize this information to basically figure out what our x, y values are based on our reference angle, okay? All right, so let's turn that off and let's go to the actual unit circle. And you can see here again that I have, basically all these right triangles, and they're all going to be special right triangles, either 30, 60, 90 degree triangles or 45, 45, 90 degrees. Okay, so now I'm going to go back and I'm going to turn off all of this stuff here. Let's turn off the 45 degrees for sure. So take those out of there. And let's take out the 60s for now. And so here, these are my 30 degree reference angles, okay? And even before that, actually, now that I think about it, let's go ahead and label first. We're going to label the axes, right? The axes are actually probably the first thing that we should do. And so let's go ahead and do that. So let's see, what color do I want to use? I want to use let's use like a light purplish color here. Okay. Okay, so here we go. So if this circle, this unit circle, is centered at 0, 0, okay, centered at 0, 0, and the radius is 1, then this value here must be, and I should probably put, let's go ahead and put in the degrees first, I guess. This is going to be 0 degrees. Okay, that's my reference angle, which is also the same thing as 0 pi. Okay, and the xy value is going to be what? Well, if the radius is 1, then I'm 1 to the right and I'm 0 high. So there you go. Okay. And let's go ahead and label this one here now. So we can piece this together pretty quickly. So this is 90 degrees, or in this case, it's pi over 2, because over here we have 180 degrees, which is the same thing as pi. Okay. And I probably should do these in a different color for the actual amounts. Yeah, let's do that. Sorry to have to undo a lot of this stuff, but that's okay. 0 degrees, and then let me choose. Let's do all these in yellow. So the x and y value are going to be, what did we say? It's 1 and 0. Okay. And then we're going to go back here. Let's label the rest of these. So 90 degrees, let's say 180 degrees. That's supposed to be an 8. This is 270 degrees, and getting us all the way back around to 360 degrees. Okay. And then let's do our radians here. So here we have 0 pi. Well, at 180 degrees, that's a full pi. Okay. So at 90 degrees, it's half a pi, so pi over 2. And at 275 degrees, I'm sorry, 270 degrees. I don't know where I thought of 5, probably because my handwriting's sloppy. But anyway, so this is 3 pi over 2, or 1.5 pi. And then coming all the way around, it is going to be 2 pi at 0 degrees. So these are all equivalent. Okay, and finally, let's go ahead and plug in our, figure out our x, y values here. So here I'd have a x value of 0 and a y value of positive 1. Over here, I would have an x value of negative 1, a y value of 0. And for my 270 degrees, which I really don't have a lot of space here because this is going to fill in pretty quickly, I have, let's see here. So this one would be, actually, let's put this over here. This one would be at 0 and negative 1. Okay. All right. So with all that being said, I think what I'm going to do is, I was going to get rid of the 0, 0. We'll see. I might have to get rid of that later on. But let's go ahead and we're going to now add in our 30 degree angles here. So what does that mean? That means that my 30 degrees reference angle is right here. Okay. And if I went ahead and I put in this right triangle, let's go ahead and add those in here. If I made this the right triangle, then that would be a 30, 60, 90. And remember, the radius or the hypotenuse is 1. Okay. And so how am I going to get this? Let's go ahead and put this down here, this x value. Because where I'm going off to the right, that corresponds to my x value. And actually, let me go ahead and with purple, I can put my, should probably start making this a little bit smaller. Hang on one second. So I don't run out of room. The width of this is a little bit large here. So at 30 degrees, which by the way is the same thing as pi over 6, okay, and you have to become proficient with these. And the way that I can figure out this is pi over 6 is because when I turn on the 60 degrees, the 60 degree angles, right, if this top half is a full pi, well, how many pieces of this pie am I taking? Well, 1, 2, 3, 4, 5, 6. So at 30 degrees, that must be a sixth of a pi. Okay. So anyway, let's go ahead and get back to this here. Turn 60s back off, and we'll put our 30 degree triangle in there. So anyway, so going back to the actual measurements of my x and y. So let's go ahead and put that in here. So my x is going to be how far right I'm going of this point right here. So this here is my point, right? Probably fill these in with yellow, so that'll work. So anyway, so the question is, what is this point, right? And so what this ends up being is this value down here, which happens to be the cosine of 30 degrees. Okay, now the cosine of 30 degrees, if you remember our right triangles here, this was 1, this was 1/2, and this was root 3 over 2, right? And actually, maybe let me put those in here with trying to color coordinate this as best as possible. So let's go ahead and put this as 1. We'll say 1/2, and this is root 3. Whoops, can't see that. Root 3. Still can't really see it, but anyway, root 3 over 2. Okay, so basically what that is saying is that my x value must be root 3 over 2. And my y value going up here, the y value going up is going to be 1/2. And there you go. That's how we got that original x and y value. Okay. Now, let's go about, I'm going to take away, let's see here. I'm going to take away this 30-degree right triangle. And yeah, those notes are still going to be in there, and that's fine. But actually, I'm kind of putting these notes on the wrong thing, but that's okay, whatever. But anyway, let's go ahead and add in our 60s now. All right, and basically, I'm going to do the exact same thing, all right? But I'm not going to write out all of it, okay? Actually, I'll write it out, but then I'm going to take it away, okay? So with my 60-degree, whoops, wrong one. With my 60-degree angle here, so that means that, let's see, do I want to do this in a different color? Yeah, we'll do it with green still. That means that this guy here is 60 degrees, right? This whole thing right here is 60 degrees, which means that this is 30 degrees. And if I have a hypotenuse of 1, right, then what is the length of the short side, which is the x value? Well, that's going to be 1/2 down here. And up here is going to be root 3 over 2. Okay? So let me go ahead and take those away, actually. Get those out of here. Actually, I'm just going to undo them. Okay, and whoops, wanted to keep that. All right, so let's go ahead and write this out. So here I have 60 degrees, which is the same thing, by the way, as 2 pi over 6, which most of the time I write as 2 pi over 6, and then I go ahead and simplify it later on. So I'm going to leave it as 2 pi over 6, and then probably later we'll simplify that to pi over 3. All right, but let's go ahead and write out what our x and y values are for this particular point here. And so for this point, let's see here. What did I say? So we had 1 up here, which means that the x value is going to be 1/2 based on our 30, 60, 90 rules. And our y value is going to be root 3 over 2, which, as you can see, this 60 degrees is the same. The values, the coordinates are the same as the 30 degrees, except they are flip-flopped. The x and y's are flip-flopped. Okay? All right. So I think what I'm going to do now is I'm going to go ahead and label the rest of these, and then we're going to basically get rid of everything, which is probably going to be, I kind of put these notes on a different side here, so we might not be able to get rid of some of it, but that's okay. But anyway, so let's go ahead and put in the rest of these, I suppose. Okay, so I'm gonna go ahead and put these all in the 60. So here we go. So if I continue labeling these as degrees, and let me get rid of these triangles now at this point, because I can take these and these coordinates and just reflect them at this point in time. Okay, so let's go ahead and do that. So we're going to reflect let's label these first. Okay, so at this angle here I have what is it, plus 30, so 120 degrees, 150 degrees, 180 degrees, 210 degrees, 240 degrees, 270 degrees. This would be 300 degrees. And this would be 330 degrees. You can see my 3. I should probably remove this 3 pi over 2. It's really going to get in the way, but that's okay. All right, and let's go ahead and continue writing out the radians as well. So here I have 1 pi over 6, 2 pi over 6. This is going to be 3 pi over 6, or pi over 2. This one's going to be 4 pi over 6. So let's write that over here, 4 pi over 6. This one's going to be 5 pi over 6. This one is going to be 6 pi over 6, which happens to be pi. 6 over 6 is 1, and that's 6 pi over 6 is just pi. And then we have 7 pi over 6. You continuing. 8 pi over 6. And let's put this in here with this guy. 8 pi over 6. 9 pi over 6, which is 3 pi over 2. And then we have 10 pi over 6. And then 11 pi over 6. Whoops. 11 pi over 6. Okay. So now we have all of our angles in both degrees and radians. And at this point in time, I'm just going to go ahead and simplify these, right? So 2 pi over 6, I'm just going to go around the horn here. Let's make this a little bit smaller. So 2 pi over 6 is pi over 3. All right. And by the way, if you were getting tested on this or something, you really want to make sure you simplify all these. 2 pi over 6 is, 4 pi over 6 is 2 pi over 3. 5 pi over 6 is good. 7 pi over 6 is simplified. 8 pi over 6 is going to simplify to 4 pi over 3. And let's see here. 3 pi over 2 is good. 10 pi over 6 is 5 pi over 3. 5 pi over 3. And 11 pi over 6 cannot be simplified. Okay? All right, so all that's left for my 30 degrees and 60 degrees is to go ahead and reflect this thing. Okay? So let's start with all of our 30 degree reference angles. And I'll go ahead and just put in here, let's go ahead and put in our triangles here just so you guys can see exactly what these are. So for our 30 degree reference angles, right here I have root 3 over 2 and then 1/2. So let's go ahead and reflect this over the y-axis. So when I reflect this over the y-axis, this becomes negative root 3 over 2, comma 1/2. Now I'm going to reflect this point all the way down here. And so all that's going to change is the y. So in this case, this one is, whoops, negative root 3 over 2, comma negative 1/2. And then again, I'm going to reflect this over the y-axis. Or you could think of this as the original reflecting over the x-axis. Either way, you get the same thing. But anyway, this would be positive root 3 over 2 because the x is in the positive. And now the y is going down negative 1/2. Okay? All right. So what I'm going to do now is I'm going to fill in the rest of this unit circle. Let me turn off the right triangles here. So I'm going to fill in the rest of this unit circle. And let's see what gets turned off here if I do this. And we're going to turn off the 60s and the 30s. So I'm kind of like left with this little green area. Maybe what I can do is take out that little green area there. And so let me go ahead and do that. Let's see. Get rid of that. Because now what we want to do is the 45 degree angles. Okay, so that looks good. And so let's bring in our 45 degrees. Yeah, I know this one extra point is hanging out there, but that's okay. And you know what? Let me erase that too. What the heck? I'm going to erase it, and I'll go back and fill that in. Let's go ahead and I'll do this the right way. Let's fix it before we continue on. And so that was part of my 30 degrees. And if I have my 30 degree notes here, what was this? Let's see here. So this looked like, actually I put it in my 60 degree notes, I believe. So 60 degree notes. And so let's see here. So this guy, this point right here, just to fix this, is going to be a 30 degree angle. And that is at pi over 6. And the point, the x and y coordinates of that is root 3 over 2, comma 1/2. Okay, and now I can turn that back off. Sorry about that. And so let's go ahead and now we're going to take care of our 45 degree angles. Okay, and so let me turn off this real quick. And so this one's going to go very, very quick and very easy because these are all the same, right? So if I turn this on, you can see that this angle, let's do like an orangish color here. This is 45 degrees right here. And so if this is, hypotenuse is 1, I need to divide by the square root of 2. But then when I rationalize, you end up with root 2 over 2 for along the x. And then going up, right, up is also root 2 over 2. So when you create this triangle, at 45 degrees, and maybe I'll put in purple here. Let's do that. So this would be at 45 degrees, which, by the way, if going one semicircle over is pi, and I'm dividing this into 4, then that would be pi over 4. Okay. All right, and so let's go ahead and list our x and y values. So for the x value, that would be the cosine of 45 degrees, because this is adjacent to the reference angle in SOHCAHTOA. And so that would be the square root of 2 over 2. And the y would be the sine based on this reference angle. So that would be the square root of 2 over 2 also. And so I'm going to go ahead and turn this off now, or some of this off, I suppose. Well, actually, you know what? I'll leave them on first for now, and then we'll turn them off afterwards. But let's go ahead and now let's go ahead and reflect these. Okay, so first of all, this is 45. Actually, before we do that, let's go ahead and label the angles. So 45 plus 45 is 90, plus another 45 is 135 degrees. And then plus another 45 is 180. Plus another 45 is 225 degrees. And then 270 plus another 45 is going to be 315 degrees. And now let's go ahead and do our radians here. And I'm going to go ahead and simplify right away. So this is 1 pi over 4. 2 pi over 4 simplifies to 1 pi over 2. 3 pi over 4. 4 pi over 4 simplifies to pi. 5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2. And then 7 pi over 4. And that does not simplify at all. And then 8 pi over 4, which does simplify back to 2 pi. Okay, so we're all good with our labels. And now let's go ahead and put in our points here. So this point here is going to be, if I can fit it in here, this is going to be negative root 2 over 2, and then positive root 2 over 2, because the x, yeah, I can't really fit that in there. Let me move this over a little bit. So negative root 2 over 2, comma root 2 over 2. All right, because the x is going from the positive over to the negative side, and the second, from the first to the second quadrant. And then we're going to reflect it down here, negative root 2 over 2, comma root 2 over 2. Oops. Negative root 2 over 2. Sorry about that. The y is also going down, of course. And then finally here, we're back to positive root 2 over 2 for the x, and negative root 2 over 2 for the y. Okay. All right, so that actually completes the unit circle, and I'm going to go ahead and turn these back on so you guys can see the entire unit circle labeled here. So there's everything. Okay, so, oh, and it looks like I forgot one of these, didn't I? So let's go ahead and, whoops, label this guy here, the 60. So let's go ahead and plug this in. So I don't know how I missed that, but anyway, so I am going to reflect this one over, right? That's the one that lines up here. So that is going to be negative 1/2, and then positive root 3 over 2. Okay. All right. So there we go, and it looks like, yeah, it looks like I missed all these 60s. I think I just did the signs. It looks like, yeah, that's the problem here. So I'm gonna go ahead and reflect this one down as well, to the 120 down to the 240. So this one is also gonna be negative 1/2, and then negative root 3 over 2. And then I'm gonna go ahead and reflect this guy over to the 300 right here, which is going to be positive 1/2, and then negative root 3 over 2. Okay. All right, so yeah, there you go. That completes the entire unit circle. And there's one thing that I didn't actually explicitly say, but you've seen me do it over and over and over again. And this, again, has to do with there being lots and lots and lots of patterns here. And it looks like I left on my triangle there. So anyway, so lots and lots and lots of patterns here. And what I want to show you now, or the last thing I want to hint at, is really important. The X and the Y, every single one of these mapped to the cosine of the reference angle for the X, and the Y mapped to the sine of the reference angle. So that is really important for the unit circle. We note that it's a radius of 1. It's centered at the origin. And then also something that you'll know through repetition is that over just recreating this over and over and over again is that the X always maps to the cosine of theta of the reference angle, and Y maps to the sine of that reference angle. All right, so there it goes. That is the entire unit circle, and there are many, many other like pseudo patterns or whatever you want to call it in naming these. And I'll leave it kind of up to you to check out. But just to recap, the way that I like to create it is all I remember is the 30 degree, that 30 degree triangle, and I'm good. I know 30 degrees, it's the x is root 3 over 2 and the y is 1/2. From there, I can go just keep going over 30 degrees, 30 degrees, 30 degrees to come up with 90% of the unit circle. And then I go back and I do my 45s, which is just root 2 over 2 for both the x and the y. And you just reflect it. Okay, so that's it. Hopefully you guys enjoyed it. I know this was a really long one, but you know, the unit circle can be quite a large topic to cover. So, but I hope you enjoyed the video. All right, see you guys later.